All right, so for exercise 3, our fraction is supposed to equal 3/5. And I'm trying to come up with a formula that's going to find the coordinates for point P that is 3/5 of the distance from point A to point B. It's going to be a weighted average. We just have to figure out what the weights are using the inductive reasoning skills that we developed through the course of this lesson. So, would you agree with me that we're going to be dividing by 5, right? I'm going to break this up into fifths, so I should be dividing that whole thing by 5. And then we need weights on our x1 and our x2. x1 is going to be multiplied times something, and then x2 is also going to be multiplied times something. We just got to figure out what those weights are. So remember the weight, which is the numerator of our fraction, the 3, it goes not on the x1, but it goes on the x2. And hidden inside of this partitioning formula is that fraction, 3/5. This is going to be 3/5 right here. Let's get rid of this question mark. Put a 3 in its place. 3 x2s. What about x1? So what we discovered for the other weight, it's the piece of the segment that's left over. If I took 3 out of 5, how much is left over for the distance from P to B? So 5 minus the 3 gives us 2. So the weight for x1 is going to be 2. So our formula then to find the fractional points, or the point that's the fractional distance 3/5 from point A to point B, is 2 times x1 plus 3 x2s, all of that divided by 5. All right, now let's take it one step further. This is going to generalize it, so instead of having specific numbers like the 2, the 3, and the 5, we're only going to have the A and the B. So here is that picture. So same kind of deal, same thing as before, but again, we don't have numbers here. We have variables, and sometimes that makes it a little bit more challenging. So once again, I would like for you to see if you can do this on your own. So see if you can find the formula, basically, that's going to find the point P, which is a fractional distance A over B from point big A to big B.